So here's the E2 reaction mechanism. This is an elimination now, so nothing is substituting, nothing is adding, we're only removing atoms in this case. So instead of calling it a nucleophile, now we're calling our active reactant here a base. The E2 mechanism is all in one step, so there's no intermediates, there are multiple arrows to get there. So we start with the base, acting like a base and taking a hydrogen atom. The electrons between carbon and hydrogen get moved down to between these two atoms. That forms our pi bond there. And then the leaving group is broken off with the electrons going to the leaving group, giving us our negative charge. So overall, we've got one step with three arrows. Right? We've eliminated hydrogen from the structure and eliminated a leaving group and left behind a new set of pi electrons to make this work. So same thing here. Our example of our 2-bromobutane. So in his case, the skeletal structure doesn't have the hydrogens drawn, so it puts them in. Real important not to react here. There is a hydrogen here, but if I remove that hydrogen, there's nowhere for the electrons to go. It's not the way the mechanism will work. So same steps as before. So base takes hydrogen. Right, electrons go in between that carbon with the hydrogen and the carbon with the leaving group, and then leaving group comes off as well. Right, so I've made a bunch of changes here. So when I'm drawing, start with the simple carbon skeleton that hasn't changed. Right, carbon bromine is gone, just leaving Br minus left over. Right, I've lost the hydrogen, and its electrons went to form a double bond here. Right, that hydrogen went to hydroxide, which is going to give me water. Right, so that's our E2 mechanism. There is some stereochemical concerns here, and in general, you'll always look at the trans form of the double bond, if possible, but there's more details than that. But this is just the simple arrow mechanism to look at.